Hello everyone and welcome to this demo on the ASR9001 cluster. I will show you the process of clustering two ASR9001 chassis. I will also walk you through some hardware and software requirements and also some show commands that would be useful once you cluster two ASR9001 chassis. My name is Kashish Golani and I'm a technical systems engineer at the Cisco Customer Proof of Concept Labs. So in order to cluster two ASR9000 chassis, there are certain requirements that you need to keep in mind. You need to connect the EOBC links between the two chassis. They are pretty much the links that will carry the control plane traffic, and they will be used for the synchronization between the two chassis. These are the special NV ports that you can find on the RSP440s. They only support 1 GiG Cisco optics, and currently there is only layer 1 transport that is supported for these EOBC links. The other links that you need to connect is the interact links. This is used to carry the data traffic between the two chassis. You need to have a minimum of 2 and a max, and you could have up to 16 links as interact links between the two chassis. There are implicitly bundled, so there will be load sharing between the two. They only support 10 GiG Cisco optics and layer 1 transport. The other links are the regular data links that you will use, and they could reside on the same line card as the interact links. The RSP that needs to be on the system is the 440s. You cannot have the older RSPs or the older line cards, the Trident line cards, on the same box. Even if you are not planning to use it, it cannot even coexist in the same system. If it is present, you will be unable to form the cluster. You need to have a cluster software license. The software version has to be 4.2.1 or above. Currently, we only support like-to-like chassis. There is no presently there is no support planned for mixed chassis support. For the 9006 and the 9010s, you need to have dual RSP per chassis. A single RSP per chassis is supported, but it is not recommended. Cisco is not it tells you not to use it because it's not recommended due to the lack of fabric redundancy on the physical chassis. There are certain limitations. The inter-chassis data link will not support any 40 gig or 100 gig. There is also on the inter-chassis data link, there is no QoS support. There is nothing that you can go and configure. So for these inter-chassis data links, you cannot configure any load balancing, you cannot configure any QoS. Everything is done implicitly for you. There is nothing that you can configure on these links. For the EOBC links, again, they are user configurable. There is they only plug and play. You cannot configure it or view it. Also, you have to keep in mind that if you want to convert two chassis into a cluster, there is currently no ISSU-like support. You need to have a downtime for around maybe more than 15 minutes for you to convert this two systems into a cluster. So this is how you need to connect the EOBC links. This is the 9001 chassis. So there is a single RSP and you have two NV ports on each chassis. You need to connect port 0 to port 0 and port 1 to port 1. And the interact links, again, you could use the built-in 10 GiG ports, and you need to have a minimum of 2 interact links. For the 9006 or the 9010, it's different because you have 2 RSP per chassis. So the way you connect the EOBC links is slightly different. So you need to keep in mind that they are connected in this way for them to form the cluster. So let me now demonstrate to you the process. And so I have This is my connection to two different chassis. This first one is called rack 0 and the other chassis here is called rack 1. The first thing you need to note is you need to check if they both are running the same software version. So this one is running 510. This one is also running 510. The other thing you need to note is you need to check if there are any inactive packages on the disk, because if there are, it's better that you delete them and remove them, because that would just add on to the time that it takes to form the cluster. Because during the process, the rack 1 would try to will sync up all the packages from the rack 0 disk, and if you have a lot of inactive packages, it will take a longer time. So make sure you clean up your disk on rack 0 before you start this process in order to shorten the time to form the cluster. So the first thing to note is you need to get the chassis number of or the serial number of both the chassis. So for my rack 0, the serial number is this one. And for rack 1, the same thing. Once you've got the chassis, the serial number of both the chassis, the next thing you do is you need to bring the rack 1 to ROM 1. In order to do that, you need to configure the boot variable to boot it to ROM 1. The one thing to note is take a backup of the rack 1 configs if you need, because once it forms the cluster, it's going to delete all its configs. It's going to delete its entire the contents of the disk, and it's going to copy the configurations and all the packages from the rack 0 disk. So you need to make sure you have a backup of all the configs if you need them later. So I've changed the config register to boot to ROM 1. And I have reloaded the box. So now it's going to fall down to the ROM 1, and then we can start the process of forming the cluster. The one thing to note is the time. As you can see, it's around 11:37, so that's the time when we have started the process, and we can see how long it's going to take to form the cluster. So it's come to the ROM 1, and now you need to make sure there are certain variables that are set correctly before you start the clustering process. So the first thing you need to note is you need to unset the boot variable, because in this one it's booting from its own disk. You need to unset it so that it boots from the rack 0 boot disk. If you see this cluster rack ID variable, if this is set, you make sure you unset it, because if there is a case when you're using an RP which was used before, if this cluster rack ID is set incorrectly, you might come into issues. So make sure it is reset, it is unset, and before you start the process. So once you've unset it, once you've unset both the boot variable and the cluster rack ID variable, make sure you save it, check that it's correct, and that's it. That's all you need to do. And now you need to wait you need to change the configurations on rack 0. So come to rack 0, and what you need to do now is to, first thing is you need to configure the NV cluster configs. Numbers of both the racks. So you put the serial number of rack 0, what we had saved before, and specify that it is rack 0. Then you put the serial number of rack 1 and specify that it is rack 1 and commit it. Once you have done this, now you need to make sure you make the physical connection. So you need to physically connect the EOBC port of both the chassis. So you can see here it has got the NV Edge configurations that are needed. Now the one thing to note is because this is a demonstration, what I had done is I had initially already made the physical connections. I had connected both the OBC ports and I had disabled it here just so that the two chassis don't start talking to each other before I make all the changes. So now what I need to do is I need to go ahead and enable both these links so that they both become active and the chassis can talk to each other. When you are doing it, you obviously will not disable it. You will just after you've configured the NV Edge commands, you need to go and go into your lab and make the physical connections between the EOBC ports. So as you see, I've removed the disable commands. So in that, both of them will be enabled and they will talk to each other. Once you've done that, now you need to go to your rack 1 and reset it. Here you can see that both the ports are up. Reset and then boot. When you do the boot command, it tries to send a validation request to rack 0 and it will get a remote image to boot. So this is the image it is getting from rack 0 and it will try to perform a TFTP download and boot and copy that image onto its own disk and boot from there. If you look at this, this is important. You need to make sure that it has received a response. It knows that it is rack 1. This is where it's important to note that if your cluster rack ID was set to, for example, 0, then this one would come up and it would think it is rack 0 and hence the cluster will not be formed. So make sure you unset that cluster rack ID variable. It needs to know that it is rack 1 and it will get that response from the rack 0. So as you can see, it is receiving the image and once it's received the image, it will boot up from there. So as you can see, it's preparing the device. It's going to remove all the packages from its own disk. So this is where I said make sure if you need to copy some data from that disk, you need to remotely save it somewhere else because it's going to pretty much wipe all the contents of its disk and it's going to sync the disk of the rack 0. if you were trying to cluster a 9006 or a 9010 chassis which had two RSPs, the process would be pretty much similar. The only difference is that in rack 1, when you try to boot it to ROM1, you need to make sure both the RSPs fall down to the ROM1 prompt and make sure you unset the boot variable on both the RSPs, and then you go ahead and add the cluster configurations on rack 0, and then you make the physical connections on the EOBC ports. So that's the only difference. You need to make sure both the RPs in rack 1 they both are booted to ROM1 and all the variables are unset correctly. That's pretty much the only difference when you try to cluster a 9001 versus a 9006 or a 9010 chassis. Now this process is going to take some time. It's going to, once it removes everything from disk, it's then going to start copying all the contents from the disk 0 of rack 0. And what I'm going to do now is I'm going to pause this recording, and once this particular chassis boots up fine, I'm going to start the recording again, and then I will show you the logs from this point onwards. So I'll see you in a bit. Welcome back. We are now back to this rack 1. It is booted up fine. I'm going to show you exactly what happened before we left. So currently, as you can see, what we did was we had issued boot to the rack 1, and it performed a TFTP download. It received the disk 0 image, and then it removed all the files from its own boot flash and disk, and then it started the package sync. Here you can see it is syncing each and every package from rack 0. All of the packages are synced, and hence I had mentioned earlier that you need to make sure your inactive packages are removed, or else it will sync even the inactive packages to rack 1. If you can see, the time that we started this was approximately around 11:43, and it synced all the packages, and around 12:30 is when it finished copying all the images and all the packages, and then it did a self reset to boot to come up with the new image. Here is where it gets reset, and then it boots up with the new image, and the cluster is formed, and the process pretty much got over around 12:32. Now if I go to the active rack, that is rack 0, the first command you need to do is show platform. This command will tell you whether both the racks and the RPs are in the correct state. So this is rack 0 RSP, and this is rack 1 RSP. As you can see, both are in the iOS XR run state. This is the command that you need to use to see which is the primary rack and which is the backup rack. DSC stands for Designated Shelf Controller. So the primary designated shelf controller is rack 0, and the backup is rack 1. There are a few interesting show commands that you can use. For cluster function. So for the I interact links, you can use the show NVH data forwarding commands, and for the control plane links, you can use the show NVH control commands. So I will show you a few of those. This is some more information on that particular EOBC port. Now, as you can see, the first command that I did, control link uh, protocols, this is the port 0 RSP0 connected to port 1 RSP0, and one of the ports is in up and the other one is down. So that was the port on rack 0 connected to rack 1, and this is the same thing where the port in rack 1 is connected to rack 0 and it's in the up state. Now the next thing you have to do, you still have to configure the data plane link, the IRR inter-rack link. So in order to do that, you need to physically connect two ports, two 10 gigabit ports on in the chassis. So what I have done is I have physically connected 10 gig 0002 and 10 gig 0003. So now what I need to do is I need to specify them to be the date IRL links. So in order to do that, you go to the particular interface and you configure nv-edge interface command, and that command will basically configure that interface as the interact link. You need to do that on both of the chassis. Oh, and you have to do a no shot. After you've done that, the interact links also come up. In order to verify, you do show nv-edge data interfaces, or you can do show nv-edge, I think, forwarding. Yeah. So once you do this, nv-edge data forwarding location all, you will see that these are the two interfaces that we've configured as the interact links, and they are both in forwarding state. So that's it. Your cluster is formed. You can see that the rack 1, if you can log into it, and you can see that it has synced up the configurations. It has synced up the configurations from rack 0. That's all I have for you for this demo. I hope you have found this demo useful. If you have any questions, feel free to subscribe to our Cisco CPOC Google Plus page, and then you can send us some comments. We also have a YouTube channel for Cisco CPOC, and feel free to subscribe to it, and you will be able to view a lot of similar demos on various Cisco technologies. Thanks for listening. Bye.